In this video, we will be working with the Mass Defect and Binding Energy worksheet located on pages 62 and 63 of your notebook. There are 4 questions on this worksheet that all must be answered over here. All of the answers you calculate here must be recorded up here in the table. The information that we were given include the mass of the proton, which is 1.007276 units. And then the mass of the neutron is 1.008665 atomic mass units. Now, looking at our first problem. Tritium is an isotope of hydrogen. The mass of the tritium isotope is 3.0160490 atomic mass units, or we will just call it EU. So the first question asks, what is the mass defect of this isotope? Before we even start working out the problem, let's first look over here at our table. It asks us to write down the mass given on the problem. And so the mass given in this problem is this number right here. So what we want you to do is we want you to record it right next to it accordingly. So once you have recorded this here from to here, we can start working out the problem. So as I said, the question asks us what the mass defect of the isotope is. So to find this, we have to understand that right here, this symbol right here, this is a 1. And then up here is 3. The 1 is the proton and the 3 is the mass. So to find the proton of this element, we have to multiply 1 times the mass of the proton, which is located up here, which is given to us. And so once you find 1 times this number, you get 1.007276 U. So once you have completed that, look over here. The N stands for neutron. And so to find the neutron, you have to subtract the mass from the proton. 3 minus 1 is 2. So you would multiply 2 times the mass of a neutron, which is 1.008665 U. And that gives you 2.0178733 U. So once you have found the proton and the neutron, you have to add them together. So the next part of the problem is to find the total mass of the nucleon. The nucleon consists of the proton and the neutron. So added together gives you the nucleon. So this number plus this number equals 3.024606 U. All right. So once we have found that number, we can go ahead and start working on the mass defect. So the mass defect is the total mass of the nucleon minus the mass given on the problem. So it's going to be 3.024606 U minus 3.0160490 U. So once you have solved this problem, you get 0.008557 U, and that's the mass defect. The next question it asks us over here is, what is the binding energy of the isotope? So to find this, you have to use the formula. E equals the mass defect times 931 MeV all over U. So we know the mass defect since we calculated it before, which is this number right here. So what we want to do is we want to multiply the mass defect by 931 MeV all over U. So E will equal 7.97 MeV, and also recorded up here. So the next question it asks us is to find the binding energy per nucleon. So to find the binding energy, you have to divide the binding energy. You have to divide this number by 3, the mass up here of the element. So you're going to divide it. So you're going to divide 7.97. You're going to divide binding energy by the mass. So 7.97 MeV divided by 3. So E, which represents energy, will equal 2.65 MeV over the nucleon, as recorded up here. All right, so I'm going to say this. So if you notice up here, we're not rounding the decimal. We're keeping each digit past the decimal. This is necessary so we can get the most accurate answer. And then as we get to the binding energy and the binding energy per nucleon, it's okay to round. All right, so I'm going to do one more problem for you. And so the next one, the mass of a carbon-12 nucleus is 12.50 past the decimal. Okay, so it's pretty much the same problem as we did here, but some of the numbers change a little bit. So the first step is to record this number right up here in the mass given in the problem. After you have done that, we have to find the total mass of the nucleon. So as I said before, a proton plus the protons plus the neutrons equals the nucleon. So to find the proton, you have to look for this number down here. And in this case, it's going to equal 6. So we're going to multiply 6, the proton, times the mass of a proton, this number right here. And that gives us P equals 6.043656U. And then for the neutron, we're going to look over here. We're going to look at the 12, the mass, and we're going to subtract it by the proton, which is 6. So in this case, it'll also be 6. 6 times the mass of a neutron, which will give you 6.05199U. And so our next step to finding the total mass of the nucleon is actually to add the proton and the neutron together, which gives us 12.095646U. Once we have found this number, we can look at the mass defect. So the mass defect is going to be total mass of the nucleon minus the mass given on the problem, which I have written down here. And this is going to equal 0.095646U. So the next part of our question asks us, what is the binding energy of this nucleus? So to find the binding energy, we must use this problem. We must use this formula over here. E equals the mass defect times 931 MeV all over U. So we know that the mass defect is this number here, and we must now multiply it by 931. Now, the reason why we get rid of this the atomic mass unit here, the U, is because it divides out, so we don't need it. So when we multiply these two numbers together, it becomes 89.1 MeV, as up here. All right, make sure you're recording your answers in this table. So finally, for question C, it asks us to find the binding energy per nucleon. And so, as I said, we must divide the binding energy divided by the mass up here, which is 12. So 89.1 MeV divided by 12 equals 7.42 MeV over the nucleon, since the nucleon is this number right here. All right, so for this worksheet, you have to make sure that you work out every step here. And then there's also an extra credit work option if you are interested. Make sure you're recording all your data here. I'm going to provide you with the answers. However, all the work must be shown here to receive full credit. If you have any questions, please let us know. Hope you have a wonderful day.